Welcome to Chapter 6, Section 2, called Substitution. We're still looking at systems of equations, so we're going to learn how to do another method this time. So just to go over, this is for Integrated Math 1 or IM 1, and then just to go over a couple of the main screens here, or the main items on the screen. We should see a due date on our screen as a student. I don't see it on my teacher preview, but you'll see it on your screen. You also will see attempts here. We have unlimited attempts on all of our assignments, so you can come in and complete this assignment as many times as you would like. This particular assignment has 4 questions. Best score for grading policy means whichever attempt is the best one is one you keep. And partial credit is enabled, so if you do 1 of 4 questions, you credit for that 1 question. Remember, once you start your homework, you have to finish it before you can work on anything else. What that means is if I click the start button, from this point forward, if I want to leave this screen, no matter what, I need to make sure that down in the bottom right corner here, I click the Submit Assignment button. So even if I haven't started, or if I've started only a couple of them, I click that button. Number 1, it'll stop the system from locking you out of everything else. And number 2, it will actually affect the gradebook, showing your teacher what you've been working on. It makes no effect if you just close the screen. It'll save your place, but it'll lock you out of everything. So just make sure that you always click that button, because remember, unlimited attempts. You can come in and try over and over again, and it saves your place, like I said. So it's not going to make you do anything over again, as long as you've clicked the check button and gotten a green check here. On the side, we have Explanation, Example, and Message Center. So explanation tells you you're going to lose your question attempt because it is going to show you the solution to this problem. So it's not going to then let you come and type the answer in. Sorry about that. It doesn't work that way. So you'll get an X on there. You have to come back on another attempt. Example just shows you, what it is they want us to do on this one. So I'm going to walk us through this in just a minute on what they want us to do here. Once you're happy, you can close that. You can open another example if you want. And then you can also message your teacher directly from here. Reach out, ask for help. It attaches a picture of what you're working on so we know where to come help you. All right, so let's go ahead and take a look at this one. So in the last section, Section 1, we were looking at systems of equations, and it was just kind of the beginning, classifying. Remember, we have 3 types of systems. Either one solution, they actually cross. So if I'm looking at 2 lines and they actually cross, we have one solution. Or we could have parallel lines like this. I'm going to try to do my best on parallel lines so they never cross. This is no solution. And then we also have infinitely many solutions, which if I had, 2 lines that end up right on top of it, I'm not doing that perfect, but usually they cover each other up, so you only end up seeing 1 line there. So we have 3 types of solutions, and we can look at those graphically. Sometimes it's not as easy to look at the graphs because we don't always see exactly what the answer is there. So we want other methods to help us solve these problems. So when we're looking at this one and they're asking us to substitute, I want to kind of take a look at this little graphic here just for a second. We can substitute in our regular lives. So what does substitute mean? And in this case, I can have Pepsi or Coke. Now, in my case, I don't particularly care which one it is. I haven't been drinking soda for a very, very long time now, but when I was drinking soda, I really didn't care. It could be Pepsi or Coke. Whichever one you had, I don't care. They're both soda to me. Some people are very, very opinionated about this. It has to be one or the other. Or Starbucks or Costa Coffee. These are just 2 different big coffee chains. So, whichever. I can substitute one for the other, which is available. Or Domino's or Pizza Hut. Again, I can substitute one for the other. Now, some of these might cause an argument because some people are very opinionated about which goods they choose. But the idea is that they're both sodas, they're both coffees, they're both pizza. Maybe we have an opinion on which one is better, but that's not really what we're focusing on right this minute. So I can do this same thing when I'm talking about numbers and algebraic statements. So if I'm thinking of it this way, and I can say, well, these are both soda, so just give me one of them. Pepsi or Coke, it doesn't matter. Well, if I tell you, say in this problem, that y equals 15, then I can use y, or I can use 15. They're equal, they're the same thing, right? So I can use one or the other. So if I have an equation, like this one here, and I'm going to leave y in blue, and I'm going to go with red for the rest, y equals x minus 14, Well, if I know that y, I can replace it with 15. They're the same thing, like Pepsi or Coke. Well, I can just, instead of writing y, I can write 15 equals x minus 14. So that's literally the idea of substitution. I'm just swapping one thing that I know to be equal to another. So, and I know in that goods example, it's not perfect because, you know, Pepsi and Coke, they're not exactly the same thing. Starbucks and Costa Coffee are probably not the same thing. I've never actually had Costa Coffee, but, or Domino's or Pizza Hut. I actually have an opinion on that one. But, you know, it just depends on what's going on. With this one, it's not a maybe they're equal. We know they're equal. It's giving us an equal sign. So I know y is equal to 15. It's the same thing. So I'm just replacing one with the other. I'm substituting it in. So now I can go through and I can solve for x, meaning get it by itself. So I'm going to look for what's being done to the x. I want to look for addition or subtraction first. If there is multiplication division also, then I'll look for that. In this case, I'm only subtracting 14, so I'm going to add 14 to both sides. 15 plus 14 gets me 29 equals x. 14 minus 14, even though the minus is on top and the plus is on the bottom, one's negative, one's positive. Those are opposites that cancel out. So x is equal to 29 here. So this is kind of the beginning, the introduction into substitution, where I already know what one of my variable equals, and I'm just going to put it in there. I'm going to plug it in and see what I get for my other variable. So as we move forward here, I think we're going to have to kind of make a decision. Okay, so I'm going to go ahead and erase this so we don't get confused at all here. So now I have y equals 9x. So I know y or 9x are the same thing. That's what equals mean. They are the same thing. So now I have y equals 2x. Oh, darn it. I forgot to change my color. I like my colors. They're a little bit more dramatic when you change the colors. Oh, it's weird. Plus 63. So now instead of y, I can write 9x. I know they equal the same thing. I'm going to substitute y, or 9x for y. I'm just going to write that instead. And the main thing we want to pay attention to here is I want to replace the variable because I can't solve for this one. It has a y, it has an x in it. So I can't figure out exactly what the solution is to both of these lines with that one equation. I need one variable there to solve for it. So now I have a variable on both sides. I want to bring these guys together before I start, moving other pieces. I want to make sure the variables are together. So it's a positive 2x. I'm going to subtract 2x. 7x minus 2x gives me, 9x minus 2x gives me 7x. If you have me as a teacher in class, I sometimes say things backwards and I will say the answer out loud on accident. Because for whatever reason my brain leaps ahead. Or I guess my mouth leaps ahead and says it before I plan to say it. So now I have multiplication happening to the variable. I'm going to do the opposite of multiplication, which is division on both sides. Anything divided by itself is 1. So x equals 63 divided by 7 is 9. So now I know x is 9. Now I don't know exactly what y is. Remember the last one we only had to answer what is x because they told us y was 15. Well now I don't know fully what y is, but I have a little expression there. So I can go back up here and I say if I know that y is equal to 9 times x, well I can just plug x in. I'm going to substitute again, right? I know 9 is equal to x, so I'm going to, instead of writing x, I'm going to write 9. And there was already a 9 on front of there, right? Darn it. So that's going to equal, 9 times 9 is 81. So I get 81. All right. Ooh, don't zoom in on me. Check. All right. So let's keep moving here. So now we're getting a little bit more involved. So let's go. I'm going to go with blue here. So now we have two equations. One of them is solved for a variable. So we've been starting with y equals. It doesn't matter if you start with the y or the x. It really doesn't matter which one. So in this case, I already know what x equals. X equals 2y plus 13. I know it's a binomial, but I still know instead of x, I can write 2y plus 13. They are equal to, they're the same. We don't fully know exactly what that number is because we have both variables, but I know x is equal to that. And then in this one down here, I have 2x, color coding makes this a little bit more tedious, equals y minus negative 2. So, oh, dang it, I meant to change that to red. Why didn't it change to red? Just noticed that. I was writing out the whole thing and then negative 2. Okay, there we go. So now we can see this dramatic blue for the x. Here's my x here. So instead of x, I'm going to replace it. So I'm going to go like this. I'm going to space it out a little bit so I have room. So I don't have to keep going back and forth with my things here. But instead of x, I'm going to write 2y plus 13, like that. So I just replaced x with 2y plus 13 because I know they're equal to each other. So now I do have to go through and solve this guy. So I guess I'll do it in red here. So I'm going to distribute first because PEMDAS, I have to do my parentheses first. 2 times 2 is 4y, or sorry, 2 times 2y is 4y. 2 times 13 is 26 plus 3y equals negative 2. Now I want to combine my like terms here. I have 4y and 3y, so I have 7y plus 26 equals negative 2. So now I can start solving for y here. Remember, I'm going to look what's being done to the y. I'm multiplying by 7. I'm adding 26. Start with the addition or subtraction. So start with this 26. Don't start with the division. It's not necessarily wrong to do the division first, but I'm going to show you if I do the division first, I'm going to end up with a bunch of fractions. I don't really like dealing with fractions. I know a lot of my students don't like dealing with fractions first. So if we can avoid that, we try to. And doing this subtraction or addition first helps us avoid that a little bit. So I can go minus 26 because it's being added. I'm going to subtract. That's the opposite operation there. We're always trying to do the opposite. So 7y, 26 minus 26 cancels out. Anything minus itself is 0. Negative 2 minus 26 is negative 28. I had negative 2. I went 26 more negative. So now I have negative 28. Now I can do this division. Since it's multiply, I can divide. Because that's the opposite operation that helps me cancel there. 7 divided by 7, or any number divided by itself, is 1. And then negative 28 divided by 7 is negative 4. So now I know what y is. Y is negative 4. I need to go back because I have to answer this. What does x equal? Well, if I know what y is, I can go back to this one and plug it in. So I'm going to have x equals 2. I'm going to switch it over to red again so you can kind of see the drama here. Drama, drama, drama. I like to just see the different colors here. So instead of y, I can put in the negative 4 because I know that's what it equals. I'm just substituting it in. So 2 times negative 4 gives me negative 8 plus 13. So x equals negative 8 plus 13. They're opposites. So I'm going to subtract. So that would give me 5. 13 is bigger than 8. And I'm not looking at the positive or negative. I'm just looking at the two numbers. 13 is bigger. And now I can say, okay, 13 is positive, so it's a positive 5. So that kind of helps me know, is it going to be positive or negative? Which do I have more of? Do I have more positives or more negatives? I have more positives because 13 is bigger than 8. All right, so positive 5. So this is a coordinate. 5, negative 4. I can graph this because it would look like a coordinate like this. It would go 5, negative 4. And this is the point at which these two lines would cross. And I know I had Desmos open here. So this is another one where we can use Desmos. Is it .com or .org? Desmos.com /calculator. If you just look up Desmos, a lot of the time this is the one that comes up. So I can even test this and go 2x plus 3y equals negative 2. And it will graph this line for me. I'm zoomed in too far. That's why I can't see it. There we go. And I can see it's green here. I can change the colors as I want to, but it tends to give you different colors when you choose the next one so that you can kind of see the difference between the two. 2y plus 13. So there we go. We can see where it lands, and I can see, yep, that's in fact the coordinate that we just got here, 5, -4. So this is just another visual way to see the solution. It's where they cross. All right, let's go ahead and check that, and we're going to do one more of these. Okay, so when we have a word problem with a system of equations, because I'm on the section with system of equations, I know I'm going to have 2 equations to go with this. A lot of the time we're going to have 2 quantities that we're comparing. So let's kind of take a look at it, and I can tell you what I mean by that. So Keisha will rent a car for the weekend. So we can think of, here's Keisha, and I'm not real great at drawing a car. There we go, some kind of car. So she's renting a car for the weekend, okay? She can choose one of 2 plans. So I know I'm going to have plan 1 and plan 2, like that. The first plan has an initial fee of $53, and it costs an additional 11 cents per mile driven. So I have cost and I have miles driven. Those are my 2 quantities that are kind of being compared here. So the initial plan, or the first plan, that's going to cost $53. So this is my starting point no matter what. No matter how many miles I'm driving, I have to pay that initial fee of $53. That's my starting point. Plus, because it's additional, I'm going to pay 11 cents per mile. So plan 2, and I'm going to put this in red. I should have written it in red here because I just like to have 2 different colors there. The second plan has an initial fee of $46. So this is my starting point, my initial fee. And plus 13 cents per mile. Okay, so I have 2 situations here. This is the amount of money I'll be paying. So if you were looking at, I believe, that might have been section 1 we were looking at that. Let me check really quick. Yeah, in section 1, we actually had a problem just like this where we were looking at the cost of 2 different plans, and in that case it was a cell phone plan. So this is a way to compare options. Which one is better for me? Am I going to drive more or less? Depending on which plan, it will cost me more or less, which one I choose. So we don't automatically want to choose the one that costs less if we're going to drive more miles, because the more miles we drive, the more it's going to cost us. This is $53 starting point. It's only 11 cents per mile, so it doesn't sound like a lot, but if you're doing a lot of driving, those 2 cents will add up over time. So it just depends again on how much you're driving. So their first question is, for what amount of driving do the 2 plans cost the same? So we kind of need to build an equation here, or at least an expression for each one. So we're going to choose an amount here. Let's say C, which I'm going to say cost, and that's going to equal our starting point plus our additional. And I'm going to say, instead of per mile, I'm going to go times M for miles, okay? So per means times, mile, we're going to replace with M. We're doing some more substitution here, aren't we? So 53 plus 11 cents per mile. The cost for the second one is going to be our starting point. So, nice if I switched my colors here. 46 plus, again, per mile, 13 cents per mile. And we want to know when they will cost the same, when these C's will be equal to each other. Well, if this C is equal to $53 plus 11 cents per mile, and this C is equal to $46 plus 13 cents per mile, I can replace either C with one of the expressions. It doesn't really matter which one I replace. So what I'm going to do is I'm going to replace this C. Instead of writing C, I'm going to replace it with this binomial here. So I'm going to write 53 plus 0.11m. and I'm replacing that C with this amount. I know that's what C needs to equal. Equals $46.13 M. So I can substitute the entire side for C. I want to know when they're equal to each other. So I have an equal sign here. I'm going to solve for M. How many miles will it take for them to be the same? So what I want to do is I want to bring my variables together. So I'm going to subtract 11M from each side. And I tend to choose one that's going to get me a positive. So 13 minus 11 is going to be positive. So if I moved the 13 to this side, it would have been negative. So that's the only reason I moved it that direction. Really, you get to choose. Any one of these four numbers would have been correct to start with. It doesn't matter which one you start with. You just have to start moving something. So I tend to do variables first just because that's my preference. So the 53 came down, the 46 came down. Now I have 2 cents left over. Okay. Now I'm going to bring my 46 over because now I'm solving for M. Now I need to start getting M by itself. So I have plus 46. I'm going to subtract 46 from both sides. So let's see, I end up with 4, 5, 6, 7 equals 46 minus 46 cancels. And now I have 0.02 M. So what this is saying, this is the amount, the extra charge. It's the difference between 53 and 46. So it's the difference in their initial fee. And this 2 cents is the difference in their miles fee. So I'm comparing the difference here. That's what I'm doing. So now I want to do this division here. I'm going to go divide on both sides because I'm multiplying by this 2 cents. So I want to divide because anything divided by itself cancels out. So this will tell me the number of miles. And they did give us a calculator on this one. So I want to find out how many times does 2 cents go into $7. So 350. And so after 350 miles, one plan is going to start to be more than the other. So at that point, this is where they cross, and they're both going up like this. I'll do, let's see, blue. So this one's, whoops. Blue starts a little higher, like that. So blue started at $53. Red started at $46. They're both going up, but because blue, or plan 1, is only going up by 11 cents, it's going to start to be cheaper at this point. It's not going to go up as fast, and these lines aren't perfect because they should probably be quite a bit closer to each other. It's only a 2 cents difference there. But this is at the 350 mile mark. They're going to cost the same. So we know it's 350 miles. And then the second question is, what is the cost of these two plans? So really what I want to know is, what is this expression equal? Either one. Shouldn't matter. So if I take this, and I'm going to use the calculator here, I'm going to go 53 plus 0.11 times 350. So I'm plugging it in here. 350 times 11 cents. That'll tell me how much it costs for the miles, plus the $53. Let's see, go ahead and equal. So $91.50. And I know it doesn't put the 0 in here because it doesn't necessarily know we're talking about money, but make sure you put the 0 on there. If I go and I do the same thing on this one, I should get the same cost. 46 plus 0.13. Why is it not typing? I didn't look up when I was doing that. Plus. Times 350. And that's going to equal, oh, look at that, it's the same. They should be the same. If you plugged them in and you got different answers for these, something went wrong in the math here. It should be the same for both because they should both come over here to the same cost. This should be the new cost here. So this is going to be $91.50, and this is definitely not quite right as far as the scale goes here, but it's going to be above where we started on both of these guys. So we had 350 miles, and it's going to cost $91.50. And after that point, depending on how many miles we're driving, will kind of help us decide which plan to choose. So if we're going to drive less than 350 miles, the red one would probably be a good one to go with. But if we're going to drive more than 350 miles, the blue plan would probably be the better one. So kind of just depends on what you're doing there and what you need. But it's just a way to compare So when we have options, we can look at that. All right, so that was section 2. I will see you in section 3.